Welcome to the Introduction to Functions. Today we're going to look at a variety of functions given their equations and graphs. We'll also talk a little bit about domain and range of graphs and functions. A relation is a set of values that have a relationship. A function is a special type of relation where a variable is dependent on another variable. Usually the range or the y values depend on the x values. Also, there's exactly only one y value for every domain value or every x value. Another way to think of it is that each x cannot have more than one y value as its partner. One of the learning goals for today is to do a little bit of identifying domain and range. Domain will be your x values or the independent variable in a function. Range are your y values. Depending on whether our relation or function is given in ordered pairs or graphs, we're going to use the set notation for ordered pairs, and we're going to use interval notation for graphs. In the first example that we'll look at the domain and range for a set of ordered pairs. One thing to remember is that when you're given ordered pairs, you always have your x listed before your y. So basically, when you're listing the domain and the range, you're just separating those two values and you're creating a list of all your x's and a list of all your y's. So we use the symbols of set notation. These are just these squiggle symbols here. -3 is our first x from this ordered pair here. Comma 5, comma -2 is the third x, and then 7 is the last x in the given set of ordered pairs. The range, similar thing. You open up your set notation. You have 4, comma 0, comma, and then you get to another 4, which is the same 4 value that's already listed, so you don't need to write it again. And then -2, close your set. Now, when you're trying to read domain and range on a graph, things are a little bit different because you're not given finite ordered pair points. You're given a graph that's continuous. So when you focus on something like between -4 and -3 on x, and you see that you have a piece of the graph right there, you can't really list those out as ordered pairs because you've got all the values in between. You've got -3.1, -3.2, -3.0005. I mean, it's infinitely forever amount of values just in between two integers. So we have what we call interval notation, which is basically symbolizing all the values between this number and that number. Now, it's going to be likely that you're going to understand this more once we actually see a couple examples, but first you need to get the symbols down. So we have symbols like the hard brackets here, which means they include the values that are right next to them, either on the left side or on the right side. We have the parentheses, which denote or are symbolic of non-included values in the range of numbers you're going to give. We have the infinity symbols we're going to use as well. You got the negative infinity for the direction that goes in the negative x or the negative y direction. Positive infinity for the positive x or the positive y. These will always have the parentheses because infinity goes on forever. It never ends at an exact value. So those symbols are the same as here. They're open symbols. Sometimes you'll have a mix of the hard brackets and the parentheses, which again, it all depends on whether the number next to them is included or not included in the graph. And we have our union symbol here, which is when you have a graph broken up into pieces that you have to make several intervals for the domain and several intervals for the range. So going back to this graph here, it is a continuous graph with no breaks. So for the domain, we're just going to give one interval. For the range, we're going to give one interval. And so I always begin with the x, which is the domain, which you got to look at your x-axis, and I always read it from left to right. So my graph here, I'm reading here and going that way. So I try to figure out here at the left, what's the lowest possible number that this graph is going to end up at. And because there's no point right here, but there's an arrow, that means it's going on forever and ever and ever. I really don't know where on the x it's going to end. It's really going to infinity. In reality, it's going to negative infinity. It's never going to end in the negative direction. So for the beginning of our interval, our range of numbers for the domain, it begins at the negative infinity at the lowest possible end for x. And then on the positive end for x, which is looking at the axes right here, the graph is going to continue forever climbing and climbing. It's technically never really going to end. We don't really know where it's going to end for x. It's also going to go to the infinity direction, but in the positive infinity. So our interval is written as negative infinity, comma, infinity, with the open symbols at each end. The range are your y values. So now you're focusing on this scale right here, or this axis for your y numbers. I always tend to kind of read bottom to up, but I don't think it really matters. So again, I'm trying to think, where is this graph going to end up at on the y-axis? And because it's going on and on forever in that direction as well, that beginning interval is also negative infinity for y. And then when I'm following it up, it's climbing and climbing and climbing. It will never end. It's going also in the positive infinity for y as well. So here the range and the domain both really look exactly the same, which happens sometimes, as negative infinity, comma, infinity. Here is another graph, and this is what I mean by a piecewise function or piecewise graph, which means the graph or the function is broken up into several pieces here, 2 pieces. That means when we create our interval for our domain and range values, we'll actually have 2 intervals joined by the U or the union symbol. So again, focusing on the domain or the x values, always try to go left to right as much as you can. So down here, I have this graph, or this piece of the graph, starting here at this number here, which is at -4 for x. And because it's a solid dot, it includes 4. So that means when we start our first interval, we've got the bracket and we've got -4 as the beginning value for that interval. We're just going to focus on this piece of the graph right here. So that's going to be one interval. This is going to be the other interval. So -4 is part of the x interval, and then at the end of the graph, this is the other x that it ends at, +1, and notice it's a filled dot, which means it includes the 1, which means we have the bracket and we have the +1 and we put a comma. So that symbol, these symbols here right here means all the values between -4 and 1, all the decimals, all the fractions, including -4.0 and 1.0, and that's one interval. Now we're moving over to this piece of the graph. This is its own interval, and it's joined with the first one with this union, this U-shaped symbol, which means union. It just means and, or in addition to. So the beginning here, I'm still going left to right here. So this piece of this graph here starts at +1 on the x. But notice it's an open dot, which means it doesn't include the 1 for that part of the interval. So we have parentheses 1, comma, and then it ends at +3, filled dot. So it has a bracket symbol with 3 at the end of that interval. So that's the domain, all the domain. The range values, Now means we're focusing on the y values. So going back to the beginning of this graph here, really doesn't matter I think which one you go with, but I'm going to do this piece. So now we're looking at the y numbers. The lowest point here for the y is at the -3. Again, because of the closed dot, it includes a -3, so we have the hard bracket, -3, comma, and we follow the graph to the top and look at the highest point and go to the y-axis and read that that ends at 2, including 2 because of the solid point union. The other piece of the graph, this little guy right here, I think it doesn't matter here if you're going to do this value first here or this value, but I'll go with the -1 since that's the leftist point here. -1 and open symbol, not including, and then it ends at the -3 value here. This is all for y. You have to make sure you're focused on if you're looking at the x numbers or the y numbers. So the range is the y. And so it ends at -3 here, solid point, so it's going to have the hard bracket, and that's the range for this graph. Here's the last example I'll put up here on the video, but if you could pause the video and maybe try this on your own first and then check to see how well you can how well you did. So we'll start with the domain again, looking at, it's going to have two pieces. It's going to be two intervals with a union in between, and then I'm going left to right here for my x's. I'm observing this piece of the graph here, which has an arrow, which means it's going on forever and ever. That means it's got a negative infinity for that part of the interval, always an open symbol or open parentheses there for the negative infinity, comma, and then over here as we go across, it's ending right here at -1, and that does not include the -1, so it's also open with a union symbol. And then the other piece of the graph here, so your x here begins at -1, so, and it's solid dot, so we have a bracket, -1, comma, and then up at the upper end here with this arrow, we don't really know where it's going to end on x. It's going to continue climbing into infinity, and so that's what we're putting there. Open always for infinity. Now looking at the range, again looking at the graph left to right, the first part of the graph here, the first piece of the graph, you see here that it's stuck here on the same y value of +1. It's kind of like a constant. So when you write that piece of the interval, you can only write it as a set, +1, closed set, because it's not a range of numbers this time. It's just one number. It's the number 1 for the y value. Then you union that with the other piece of the graph here. The lowest y value here is at -3 with the bracket, and it goes up to the highest y value here, which is never ending, so infinity. Open always for infinity.